All right, welcome to the lesson on index of refraction. If you haven't seen the intro to refraction video first, that's what you need to go do first. For the rest of you, what you need to know, what you need to understand to get this video is what refraction is in the first place, what is the phenomena, and the two ways that light can refract. And what we're referring to there is away from the normal line and towards the normal line. And if that didn't mean anything to you, that definitely means you shouldn't still be here and you should go watch that first video. What we're going to do in this lesson is determine the value of speed of light in vacuum and calculate the index of refraction of a medium. So starting off, what we have here is a little masterpiece of a diagram that shows three mediums. Medium 1 is a high density medium. Medium 2 is a little bit somewhere in the middle. And vacuum, there is absolutely no matter inside this. You can consider this to be zero density. This is a key word. Vacuum just means a space that has no matter inside of it. So there are no little black particles like medium 2 and medium 1 do. The reason I set this up is to show you, I want you to imagine that you're a person and you're walking through a crowd trying to get from point 1 to point 2. Now if you start here, you're going to bump into a lot of people, and I'm just tracing this line out because I did this before, but you're going to bump into a lot of people, and it's going to take you a little bit of time to go around and make it to the end. That took you a little bit of a while. Now if there were less people in this crowd, such as in medium 2, it's a lot easier to avoid these people. You'll get to the end a lot quicker. It's not much of a headache as compared to medium 1. But in a vacuum, there's just nobody you have to worry about, and you can sprint your way all the way to the end. Now this is how I want you to think of light moving through a medium. When there's a lot of particles, when the medium has high density, the light will travel slower through it than if there were less particles. Just imagine it like a crowd of people and you're trying to make it to the end. Now, here's a diagram that you may have seen before. I'll read the text first. What it says is the speed of light in vacuum is measured to be close to 300 million meters per second. We will denote this value with the letter C. So C is now a variable you have to have memorized, and it's going to be equal to 300 million meters per second. Now this is the speed of light in vacuum. This is the speed of light in a space that has absolutely no matter. There's no crowd to worry about. It's an open field for light. Now, when the medium is water, which is a little more dense, and glass, which is a little more dense than water, and then diamond, which is a little more dense than glass, for each step down, light travels slower. Okay? When it's a heavier medium, when it's a more dense material, light will travel slower. So that's what it says here. Light will travel slower in mediums that are more dense and faster in mediums that are less dense. Keep in mind, C is always the fastest that light can go. So the vacuum, that's where the speed of light is the fastest. And that's important to say because what we're going to start doing is comparing how fast light travels through a medium and how fast light could travel. Now when I say how fast light could travel, this means its maximum speed. So what we're going to be comparing is light's maximum speed with the speed of light in a particular medium that we're studying. That leads us to what's called the index of refraction. Now first I'll start by talking about the equation. So the index of refraction is a number that we're going to denote with the letter n. And what it does is compares two values. The first value is c, which is the velocity of light in a vacuum, 300 million, and v, the velocity of light in whatever medium you're studying. So what we're going to do is two little quick examples to demonstrate what I mean. So the blue rectangle below is made of an unknown material. The velocity of light through this medium was measured to be 150 million meters per second. What is its index of refraction? So let's know that light travels through it, and it goes 150 million meters per second. What they want is the index of refraction, which means find n. So what we're going to do is use this equation. N is equal to c over v. Now we know the value of c. It's always going to be 300 million. The question also gives us the value of v. And what we need to find out is n. So we're going to put in the numbers and just do a little bit of math. So n is equal to 300 million meters per second over the given value of 150 million meters per second. Now I wrote the units out so that I could show you that the units cancel. And when you do this math, what you get is the value 2. So n, the index of refraction of this unknown blue material, is 2. There are no units, okay? N is an index, it's a ratio. There is no unit for n. Now let's jump to example 2. The red rectangle below has an index of refraction of 1.5. Does light travel faster in this medium or in the medium from example 1? So we've got two mediums, a blue one, which we found its index to be 2, and now we have an index of 1.5, and we need to know in which medium does light travel fastest. Now, what we're going to do is use this equation to find out what the v is. And then we're going to compare these two v's, because we already know the v of the first one, and we'll find the v of the second one. So let's put in 1.5 as our n, 300 million as our c, and our v is unknown. With some cross multiplication, we get the v on top. We get the 300 million as the numerator, and the 1.5 comes down as the denominator. Now what we'll get is, we'll bring it over here because I'm running out of space, v equals, pull out my calculator real quick, 300 million divided by 1.5 is 200 million. So we get a velocity of light in this red medium of 200 million meters per second. Now the question is, does light travel fastest in this medium or this medium? Now all we're going to do is compare these two values, and we can see that in the red medium the velocity is faster than the blue medium. The point of this, guys, is that when your n is a larger number, so we're comparing 2 and 1.5, when your n is a larger number, you go slower. When your n is a smaller number, you go faster. Larger n, slower speed. Lower n, larger speed. Let's move on. So what I'm displaying here is a small table that just compares different mediums with their indices of refraction. The text says the index of refraction is a number that tells us how fast light travels in that medium compared to vacuum. A higher index of refraction means light travels slower. Now we can see this kind of clearly if we look at the n for diamond and compare it with some sort of flint glass. Now glass is a less dense material than diamond, and it's not by coincidence that its index of refraction is also lower. Diamond has a higher index. That means that the speed of light is lower. So I'll say v, and we'll say n. So higher n, lower v. That's just the relationship. Now to check that you've understood everything I've said, you can pause the video here to try to answer these questions. First is, what is the speed of light in a vacuum? Second is, what is the index of refraction? What does it mean? And third, how is it calculated? Now if you're still here, I'll show you the answers. So the summary of this lesson is that c, which stands for the speed of light in a vacuum, is 300 million meters per second. That's the number we're going to use. It's closer to 297, 298 million, I believe, but 300 million is just what we're going to use for this class. And it is the speed of light in vacuum. Now, the index of refraction, n, represents how much slower light travels in a particular medium. A higher n means a slower velocity. The equation for the index of refraction is n equals c over v. Now, this was a short lesson. If you still have any questions, make sure to get them to me. I'll try to answer them. Just know that n represents how much slower light travels in a particular medium, and we're going to use it next in our next lesson for Snell's law. But that's all for this one, so thanks for watching.